Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome, everybody, again to another episode of our show, bringing you another really great guest today involved in creating a better tomorrow for all of us. Today, we have the honor of being joined by Dr. Rita Baranwal, who is Senior Vice President, Energy Systems Business Unit of the Westinghouse Electric Company, the nuclear power unit of the Westinghouse organization, where her core focus currently is in leading their team that's developing and deploying their AP300 small modular nuclear reactor. Dr. Baranwal recently served as Chief Technology Officer at the organization, where she led their company's global R&D investments, leading technology strategy to advance the company's nuclear innovation and ultimately driving the variety of these next generation solutions for existing and new markets. Her appointment to the CTO role in 2022 actually marked her return to Westinghouse, where she was involved for over a decade in various leadership positions, global technology development, fuel engineering, product engineering. And in that period of time, she served as Assistant Secretary for the United States Department of Energy, Office of Nuclear Energy, where she directed their R&D portfolio across both current and advanced nuclear technologies, collaborating with various utilities, national labs, reactor developers, as well as other groups in academia and government. She also led the Idaho National Laboratory as director of their Gateway for Accelerated Innovation and Nuclear Program, and was recently appointed Chief Nuclear Officer and Vice President for Nuclear at the Electric Power Research Institute. Prior to Westinghouse, she was the Manager of Materials Technology at the Bechtel Bettis. There, she led a variety of R&D programs in advanced nuclear fuel materials for United States naval reactors. Dr. Baranwal is a Fellow of the American Nuclear Society. She has a bachelor's degree from MIT in Material Sciences and Engineering, master's and Ph.D. in those same disciplines from University of Michigan. And we're honored to have him with us today. A lot of really interesting themes to get into. Dr. Rita Baranwal, thank you so much for taking the time to come on the show.
Thanks for having me, Ira. Good to be here.
It's great having you. In preparing for this episode, I was taking sort of a broad look at everything you're involved in nowadays. I saw, a couple of months ago, you gave a plenary lecture at the International Conference on Applied Ceramics and Composites, focusing on sort of what Westinghouse is doing there in terms of leveraging advanced ceramics. But I thought it was very interesting because this marks around the 25-year anniversary of your dissertation entitled Synthesis, Characterization, and Microstructural Evolution of Ultrafine Oxide Powders, which was focused on these, fancy ceramic materials that were really resistant to abrasion and corrosion and all sorts of insults that could happen. Take us back a little bit, if you would. Talk a little bit about the early days and how you first got interested in advanced material sciences.
Sure. So it's interesting because especially these days, I do speak to student groups as well, and I emphasize the importance of getting exposure to a variety of different options and opportunities, because it might help you travel down a different path than you intended, or stop traveling down a path that you might currently be on. And that was very true for me when I was exploring what disciplines to pursue in college. I toured a material science and engineering department, and they brought me to the microscopy lab, and I saw this scanning electron microscope and SEM. And I said, I remember at that point, it was very pivotal. I said, whatever I can work on that will let me use that piece of equipment is what I want to major in. And material science and engineering it was. And so I did my undergraduate in that field. and went on to get my, as you mentioned, master's and doctorate. And even my first job after graduate school was using microscopes, not only scanning electron microscopes, but transmission electron microscopes, to evaluate new microstructures and new materials. And the reason that I originally went to Bettis Atomic Power Laboratory after graduate school was to develop new nuclear fuel for the U.S. Navy's aircraft carriers and submarines. And it was in part using some of the work that I had worked on in my dissertation. But if you fast forward 25 years, I have stayed in this industry for two main reasons. Mm-hmm. One was when I was still at Bettis, I had, at the time I thought it was a short straw, but it turns out to be a very big privilege. I thought I had drawn the short straw to drive a van full of summer interns down to the Newport News shipyard, which was a several hours drive one way. And we get there, and we had the good fortune of being able to tour the Ronald Reagan aircraft carrier as it was being constructed. And I remember standing inside where the reactor would go, so where the reactor compartment would sit, and staring up several stories, realizing what I work on back in my tiny little lab in little old Pittsburgh is going to help power this enormous behemoth of a ship to help defend my country. And that was a turning point for me in terms of, this is why I am in this industry, because of the power density of uranium fuel. It can be applied for many different things, but it can also be used, and it is used, to help defend one's country. Fast forward to today, and we sit in the middle of a climate emergency.
Yep.
It's a crisis. And we at Westinghouse have been very fortunate to always provide a nuclear product that has always been a clean energy product. But our time is now where we're shining, so to speak, because we can help communities achieve their decarbonization targets as they start to address climate change. So I stay in this industry because I truly want my children to inherit an environment, and frankly, a world whose atmosphere is better than the one that I grew up in. And I firmly believe that nuclear energy can do that.
Outstanding. Yeah, I really enjoyed, again, sort of going through your your extensive publications in the literature on these topics. As you mentioned, you are publishing about nanotechnologies and these interesting nanopowders, and I learned a lot of cool things, like terms like zirconium irradiation creep, and other cool terms like that. You arrive at Westinghouse, and it's here that sort of the transition occurs, where you start getting more involved in core engineering, not just of the the reactors, but the fuels themselves, and begin working on sort of I see termed as ATF, these accident tolerant fuels, where again your expertise comes into play. I read up all on coated claddings and how you doped pellets and cool things like this. Again, all using your knowledge of these sort of these ceramic systems, these important material science disciplines in creating not just a safe reactor but the safe fuel. Talk a little bit about this, because again, this theme of accident tolerant fuels, people are very concerned about that, but comes up again and again as sort of an important piece of this new nuclear era that we're in.
All right. Well, first of all, I'm very impressed on the homework that you've done. Very well done. But yeah, so there's several different areas that I have had the good fortune of working in. But let's talk about what you call, we do call accident tolerant fuel. Our product line is branded Encore, so ENCORE, so it's an Encore fuel line, but it encompasses our accident tolerant fuel. And we are working on our ATF Encore fuel line in three different phases. So the near-term phase is looking to use that coated cladding that you talked about. And what that is intended to do is to improve the fuel cycle economics. In addition, we have a fuel pellet that is called ADOPT, and that is an acronym sort of. It stands for Advanced Doped Pellet Technology, where we take the standard uranium oxide fuel, but we put in small amounts of chromium oxide and aluminum oxide. And what that does is that it helps densify and facilitates diffusion while you're sintering, while you're heating up the pellet to densify it. And it produces a denser fuel pellet. And why that's important is when the pellet starts to experience and see higher temperatures, it provides better interaction with its cladding. And so when you've got a little fuel pellet that looks sort of like a pencil eraser, and we take many of those, dozens of those pellets, and then we stack them into what's called a fuel rod, which has cladding, and you mentioned zirconium. So traditional fuel is housed in zirconium cladding. And so the pellet can sometimes interact with that cladding. So when we have improved fuel characteristics like our ADOPT fuel, it improves that interaction behavior at high temperatures. In addition, the ADOPT fuel pellets have increased oxidation resistance, which again is a better characteristic for fuel performance. So it's really exciting for us. In the United States, ADOPT was licensed by the U.S. Nuclear Regulatory Committee last year, and it has previously been licensed in Europe. So our European colleagues and customers have been using it for quite some time. But Westinghouse is one of the only fuel fabricators in the world. And so we have the capability to provide ADOPT fuel using our fabrication plant in Sweden, as well as our plant in the United States here in South Carolina.
Awesome. Yeah, I enjoyed reading about this stuff, but it's great hearing you talk about it as well, to say, well, I sort of did understand that, but that's very cool. So that's great. So again, I mentioned, you spent, sort of two periods of your career at Westinghouse, sort of in between, everything you were doing there in terms of these technologies and sort of the accident resistant fuels and the novel materials. You head over to the Department of Energy as Assistant Secretary per the Office of Nuclear Energy. And a couple of weeks ago, we had Kathy Huff on, who took the role after you came back to Westinghouse. She introduced us a little bit to the Idaho National Laboratory. I'd really like to focus on that, because here is maybe a lab. When we think about nuclear, we think of Los Alamos and so forth. We may not be as familiar with the Idaho National Laboratory, but this GAIN program, the Gateway for Accelerated Innovation, where basically, you were responsible for, in a sense, incubating over 100 companies in sort of these new technologies. I come out of the pharmaceutical industry, and I was always sort of in that role where, as much of cool stuff I could do in biotech, we always required that big pharma partner to help us move things into later development and commercialization. Talk a little bit about this GAIN program, because I think not just the amount of companies that you were involved in incubating, but just the structure of it, and the fact that we have sort of this nuclear tech ecosystem that you developed there is pretty fascinating.
Okay, so let me just clarify. I would say we definitely didn't help incubate that many companies, but we definitely impacted. Okay. So I just want to be careful because I think it is really important. Incubators have a very important place in our technology ecosystem, but I wasn't that great. But I did have the good fortune to help with driving a lot of the connections between private technology developers in the nuclear space with the national lab capabilities. So even before I went to Idaho National Lab to lead GAIN, I remember when I was at Westinghouse, there was an initiative that was put forth by DOE and several universities, and they had 6 different workshops. And basically, the objective of these workshops was to pull in from academia, government, and private industry leaders in innovation and technology development. And they asked us, they said, what can the US government do better? how can we help you commercialize your technology better, faster, more effectively, more efficiently? And that set of workshops resulted in what GAIN became really. GAIN was launched to help private nuclear technology developers commercialize their technology faster by using the U.S. National Labs capabilities, including, for example, historical data. Decades of experiments have been done. There are reports after reports with really rich amounts of data, providing access to that data to these technology developers, providing access to world-renowned experts that work at the national labs across the country in the United States, and providing access to world-class facilities that, one, are maybe rare, but also it's really expensive. Even that SEM that I talked about a few minutes ago, that's a very expensive piece of equipment. And many companies cannot it doesn't make sense to, maybe they can't afford it, or it doesn't make sense to have one in terms of a capital expense in their laboratory. And so to have access to that type of equipment, those types of facilities and people and historical data was one of the outcomes of those earlier workshops that said, this is what we need from the government. So it truly was a privilege to be able to lead that effort. We did impact over 125 different organizations. Some of them weren't even in the nuclear industry at the time, but they saw, they had a vision and they saw that they should be part of this space, and they wanted to be part of the industry. And so it was sort of their foray into it as well. We held a lot of different workshops in terms of sharing what the major technologies were going to be in advanced reactor space. So, for example, we held workshops on molten salt reactor technology, on high temperature gas reactor technology, on liquid metal cooled technology like sodium or liquid lead. We also started engaging with the US NRC and sharing with them what our community was working on, the 3 different coolant technologies, but also what was going to be needed in the future as some of these companies came to the NRC to certify their designs. And so it was, I would say, a fruitful set of meetings that we had. We had some public meetings where companies would share what they were working on with the NRC. NRC could ask questions and also provide feedback in that, providing them comments and giving them questions as well on the technology, maybe as a class more than a specific, company focused or company directed question, but more in terms of, well, how are you going to, develop materials that are corrosion resistant and need to be, operating in liquid lead? Questions like that, so that once a company came to the NRC with their design certification package, many of those questions and the answers had been anticipated and baked into that certification package. I think that one of the most flattering aspects of GAIN was that a few years later, a fusion analog was launched to GAIN's fission program. So Infuse was launched by the DOE, almost mimicking the GAIN initiative. GAIN was focused on fission technology, and Infuse is focused on fusion. And so that was certainly flattering for the entire GAIN team, in that, we're doing something right, and folks are going to start to emulate it, and that was wonderful. So it was a good 3 years. GAIN is still going strong. They have continued the mission of the initiative, but expanded it as well to very importantly, bring in stakeholder engagement, including communities as well as state stakeholders. And I think it's a great next evolution of what GAIN should be doing.
Awesome. What focusing now back, because you serve in the role of at DOE, You come back to Westinghouse. Now you're involved in sort of, much broader, involved everything at this point as CTO. We talked a little bit about the nuclear fuel work, which continues, and that's, fascinating in its own right. But Westinghouse is clearly a leader in all sorts of energy systems per nuclear, from the very large down to these more, mini and micro reactors to get into. The AP300, which is I think where you're focusing most of your effort nowadays, is sort of everywhere in the press as sort of the as we're into this zero carbon era, and are realizing the benefits of nuclear at all levels. This is the one that's kind of hot both here in the U.S. and I see you're doing a bunch of deals internationally. Take us to AP300 SMR, if you would, because I think this is an extremely important sort of evolution of the story now.
Okay, so let me start. I'm going to take one step back, if you don't mind.
Sure.
So Westinghouse has a portfolio of reactor products. Yep. Let's start with our AP1000, and so that is it's a gigawatt class reactor. It is operating successfully in China, and I am proud to say today in the United States as well.
Excellent.
Vogtle 3 just recently achieved 100% power.
Nice.
And so that is a wonderful, wonderful news story for the industry, and a great achievement for all of the teams that were involved. Hundreds and hundreds of folks were involved in that, from many different organizations. So we have our AP1000 gigawatts size class reactor. AP300 is based on that proven AP1000 technology. It is based on that licensed AP1000 technology, but it's a smaller class. Our AP1000 reactor it's what's called a two-loop reactor. AP300 is smaller, requires only one loop, and its footprint is smaller. It can fit on 1/4 the size of a soccer field. Or around the rest of the world, a football pitch. But the safety-related aspects of an AP300 plant would require 0.4 acres of land. So that's a very small footprint for a 300 megawatt electric output. Let me move on to our two other reactors. We have our micro reactor, which is our EPRI micro reactor. It's nominally 5 megawatts electric output, and that is meant to provide electricity and beyond electricity applications to remote communities, islanded communities, ecosystems that want to be behind the meter or off the grid, for example, hospitals, data centers, universities, military applications. Could benefit from a microreactor type of technology. The reactors are factory fabricated. They are shipped via truck, rail, or by sea, and they are installed at the use site in less than a month. And they can operate for over 40 years and can go as long as 8 years without needing to refuel. Nice. By comparison, a traditional power plant goes about 12 to 18 months, sometimes 24 months before they need to refuel. And so eVinci has a lot of different benefits. I'm really proud that we launched eVinci during my first go around at Westinghouse when I was director of R&D. And it was the product of some brilliant engineers who had been working some with Los Alamos, which is the root of the technology that's in eVinci. It's a heat pipe reactor. So again, Westinghouse has decades of experience in deploying reactors and maintaining them, and then when the time comes, helping decommission those reactors too. And then finally, the last reactor I want to talk about before I jump back to AP300 is our lead-fast reactor. That is what is classed as a Generation 4 reactor, and it is the one that will be deployed furthest into the future because we are still developing the technology. We're doing a lot of testing globally with some partners, several partners in Europe. But we're envisioning deployment there in the 2030s. So So that's sort of the furthest to the right, if you will, in our deployment timeline. Now, AP300, I said, is based on the AP1000 technology. AP1000 has been licensed in the United States, it's been licensed in China, and it's been licensed in the UK. So we have based this on technology that has been licensed globally, and it's been proven. AP1000 in China, the reactors that are operating continue to set records in the industry in terms of capacity factor, which means how available are they to provide electricity to the grid. In terms of refueling outages, they've had some very, very short refueling outages, which again speaks to the efficiency of the design. It was designed and constructed with that type of efficiency in mind, so that when it's being operated, it is also efficient, and when it's being maintained, it's also efficient. So it's based on AP300 is based on the AP1000 design, has a smaller footprint. We are applying the lessons that we have learned from construction in both China and in the United States to our AP300 builds. And so we also are one of the only companies around the world that can claim those types of lessons learned. We're taking it from a gigawatt scale reactor, that experience, and applying it to our SMR.
Excellent. And Rita, I watched you at a couple of months ago. You gave a presentation, talking about sort of the sea, land, space connection here. If you could you say, I mean, obviously every day we hear about this guy Musk that's shooting a bunch of rockets up into the sky. But clearly, there are plans for things happening on the moon and eventually on Mars. Can you say just a few words about your vision in terms of the micro reactor? Because that was, in preparing for, again, I was reading about, I didn't know something like this even existed. It's sitting there on something the size of a tractor trailer, but a little bit of your vision in terms of the space component of this, if you would.
Sure. I'm going to take another step back because part of my graduate work was actually funded by NASA. Nice. And so it is, to me, very poetic that I continue to be able to work with NASA on certain NASA projects. During my time at Bettis, we actually worked on a project with NASA to develop nuclear reactors to go to Jupiter to explore its icy moons. Wow. And so, that was my first kind of introduction into the nuclear industry working with NASA. That project ended prematurely, but that's okay. And if you fast forward, during my time at DOE, we did a lot of work with NASA. We helped actually craft some policy around space reactors while I was at DOE working with NASA to jointly do that. So that was very, very rewarding. And then today, Westinghouse is very fortunate to be one of the awardees of funding for the NASA Artemis project to develop a reactor to provide fission surface power for the moon. So right now we are in the middle of a one-year program, but we are absolutely planning and hoping to be part of what's called a phase 2 award, where we'll get additional funding and get to mature our concept even further. But the intent is, for the 14 days out of the month where you don't get to see the sun, the astronauts that would be, or the people, right, like you and me that might be living on the moon, need to have access to reliable electricity, and nuclear power can provide that reliable fission surface power.
Someone's just going to have to develop the anti-nausea medicine for me, because I can't go on the tilt-a-whirl at the amusement park nowadays without getting nauseous in 2 minutes. But anyway, that's a different story. Coming back to sort of the theme of innovation, which obviously is major part of your work over the years. You've constantly been an innovator, and at the same time, looking at innovation, as you sit in Westinghouse, and maybe sort of the next generation folks from academia or small startups will come to you with ideas. Talk a little bit about sort of what innovation looks like to you. What type of things do you want to see coming from sort of the next generation of startups, the next generation of concepts, and ultimately how you evaluate this stuff as you currently work on deploying the existing tools, but constantly thinking about the next 5, 10, 15 years of what's next?
Okay, so in my in my opinion, really, innovation needs to provide a value to a product or to a customer, right? So let's talk about the customer. So something that we innovate in the end needs to provide some sort of value to our customers. That can be an existing customer, or that can be a customer in the future that we currently don't have in our portfolio, if you will. And one example might be, right now we have many utilities that operate gigawatt scale reactors, but we don't have a lot of existing utilities that operate SMRs. So we can certainly sell an SMR to an existing customer, but we also hope and anticipate that we will have a new base of customers who will start to explore nuclear by deploying an SMR as their first nuclear power plant. So it's anticipating what those needs might be. And the needs of a customer who is deploying new nuclear in the form of an SMR might be different from that of somebody, of a customer that already has nuclear in a gigawatt scale format in their portfolio. So in terms of innovation, there's a few things we need to ensure that we have. One, that we have a team that is comprised of folks that are willing to take calculated risks. The nuclear industry, rightfully so, is very, very risk averse. And so to ask a group of folks to go ahead and take some risks, go ahead and fail, but do it quickly and apply lessons learned and pivot and move on is it's such a dichotomy. And so one, you have to make sure that we have the right folks with the right DNA and the mindset to be willing to kind of buck up against the general mentality of the nuclear industry. Two, we need to understand the needs of our existing customers, right? The voice of the customer. Where are their pain points? And so we do that. We listen to where the pain points are of our existing customers. And then we also scout technology outside of the nuclear industry, because not everything is going to be invented here. And it behooves us to leverage outside technology to improve our own tech, so that we can provide a more innovative solution to address those customer pain points. It doesn't really get to the customers that don't exist, but I'm optimistic that when we take in consideration our existing customers' pain points, you pull in outside technology, you also use open innovation where we might not find a solution, but we take that problem and we post it out there for all of the world to participate in and provide us solutions, and then kind of, down select and have sometimes even contests, right, for who might provide the most innovative solution to this problem. We're using all of those types of options. So we are a large company, but we're not so large, and it doesn't make sense to be so large that we can have all of these technology experts in our midst, right? So we use open innovation as well.
One other area, you gave a presentation, it was a little while ago, and you were talking about all the other applications of nuclear technologies beyond obviously providing energy. And you talked things about medical isotopes and water desalinization and things of this nature. What else, looking at a future where we have all the Westinghouse micro and mini reactors out there powering the world now, we got no more carbon. What else excites you about nuclear nowadays? Maybe that's something Westinghouse is involved in, but obviously nuclear touches on so many other areas of health and medicine and agriculture even. Take us into what else excites you?
So even our technology can be used and is being used around the world for other applications that are beyond electricity generation. So nuclear power plants can be used to provide district heating. they can be used to provide process heat. And this can be beneficial to manufacturing sites, manufacturing applications that need that reliable source of heat on a very proven basis. We have a lot of actually interest in our AP300 SMR technology from in industrial manufacturing type of operations where they want to create their own ecosystem and have a reactor that will 24/7 reliably and very cleanly help provide not only electricity but perhaps process heat and even perhaps desalinated water to their industrial site. Let's talk about water desalination for a moment. So, water scarcity is another global crisis. And currently, water desalination is a very fossil-intensive process. And no one is going to say, let's stop that because water is necessary for life. But if we can provide a cleaner way to desalinate water, that benefits everybody. And nuclear absolutely can be used to help desalinate water. So plants that are closer to a body of water that are located along the coastline can not only provide electricity, but that electricity and even some of the heat can be used to desalinate water, which is currently done in a pretty fossil-intensive way. Nuclear power can also be used to generate hydrogen, and there's a lot of interest in that at the moment. We have chosen to focus on high temperature steam electrolysis, which is definitely more efficient, but it takes a little bit more technology. And so we have partners both in the electrolyzer side of things, but also on the lab side of things. We just recently won a funding award from the U.S. Department of Energy as well to pursue hydrogen generation from nuclear power with several partners. So we're very proud of that, and we continue to work in that space. And then finally, I think what might be one of the most important aspects of nuclear energy is that it can be used to generate medical isotopes, life-saving medical isotopes. And Westinghouse is part of that as well. And so we are working not only on radioisotope generation, but focused on certain elements that can be used to detect cancer and elements that can be used, isotopes that can be used to treat cancer. And so I think, a lot of the general public doesn't realize that many of the life-saving treatments that we receive or somebody in our family or a loved one receives for medical treatment uses nuclear technology. Even when we go in for an MRI, my daughter's scheduled to go in for an MRI, and that the M stands for magnetic and the R stands for resonance and the I stands for imaging. What they dropped off from the beginning of the MRI is the N, and it's nuclear. So it's nuclear magnetic resonance. And so, these types of technologies benefit all of society, and they have for many, many decades, and they will continue to do so. You talked about agriculture. Nuclear technology is used to irradiate our foods so that it has a slightly longer shelf life and it kills bacteria, et cetera. So there's a lot of different applications for nuclear technology, and I, for one, am very proud to be part of the industry and look forward to continuing to be a part of it. I'd love to, coming back to the space piece of it, I'd love to see a reactor on the moon and beyond in my lifetime.
I'd like to see a reactor in my house. They get over and make them that small. Now
Westinghouse can help you with that.
We're a very pro-nuclear family here, so awesome. Keep making them smaller.
That's fantastic.
Rita, as I mentioned at the beginning, you a couple of months ago you were with the International Conference for Applied Ceramics. I think a couple of weeks ago you were at MIT at their Center for Advanced Nuclear Energy Systems giving a talk. Anything else coming up for 2023 that we should know about in terms of public-facing stuff, conferences you're going to be presenting at, places that we can listen to you, meet you possibly? Anything else hot on the calendar? Please take the floor.
So the biggest one, and I don't know if I personally will be there, but I know Westinghouse will, and a lot of the industry will as well, is COP28. So it's occurring in the UAE this year.
Yep.
And it's, nuclear for many years had not been part of the conversation. And so just recently, nuclear energy has been, I would say, welcomed into the COP conversation, and Westinghouse is proud to be part of that. And so I believe it's in November of this year, and we'll be there. And if I'm there, I absolutely welcome your audience to come say hi. But at the moment, I can't think of certain specific conferences, but I do share on my LinkedIn, the places that Westinghouse is, or the places that I speak. And absolutely, if folks have questions, they are absolutely welcome to reach out to me.
Awesome. Yeah, it's once again, it was fascinating reading about your journey, Rita, and obviously hearing you talk about it, and really just wishing you were the best with it as you continue to champion these programs and lead them forward. Again, for everybody that is going to be listening to this particular episode of our show across the various podcast networks, or watching on our YouTube channel, you've been listening to Dr. Rita Baranwal, Senior Vice President, Energy Systems at Westinghouse Electric Company. Rita, again, I want to thank you for taking the time out of your schedule to come talk to us for a little while today. Thank you for everything you're doing to help us power the zero carbon future. And as we like to say here on our show, thanks for helping to create a better tomorrow for everybody. Really, really great story.